Okay, so let's look at another contingency table, and it's actually the same one we had before. So we need to talk about with replacement and without replacement. So what's the probability of randomly selecting two people with replacement who use social media? Okay, first of all, are the events independent or dependent? So the first event is pick the first person who uses social media. And the second event is picking a person who uses social media. So how do we tell if they're independent or dependent? Well, the key here is with replacement. When we replace it, we pull one out of the pile, we see what it is, we put it back in. That means the next time we pull something out of the pile, we are in the exact same spot we were the first time. That means it's independent, because the probability does not change since we're putting that first person back in the pile. So independent goes with replacement. So find the probability. Well, we need people who use social media. So using social media, there's 338 people that do that out of 530 total. So the probability of first person use social media and the second person uses social media equals the probability that the first uses social media times the probability that the second uses social media, given that the first also uses social media. So remember, they're independent. So when we pick the first person, we have 338 total people in that category out of 530 total people. So that's the probability of the first one. Now we pull one out. We say, okay, you use social media. We put them back in the pile. That means we still have 338 people that use social media we can pick from out of 530 total people. So we just put that in the calculator and we get approximately 0.40671, or if we round to 3 decimal places, which we probably should, 0.407. Now, be careful when you do the homework in the MyLabs Plus, because Pearson will frequently change how many decimal places it wants you to round to. So always read the problem carefully. If you don't see anything about how many places to round to in the problem itself, look after the answer box, and usually there will be a set of parentheses with some navy blue words in them that tells you how many places to round to. Okay, so that was the first part. Now let's look at part A. What's the probability of randomly selecting two people without replacement who use social media? So this time, without replacement, that's like the previous problem we did with the donuts. If we eat a donut, we cannot replace it back in the pile, right? So anytime you see without replacement, that goes with dependent probability, because we take one out of the pile, see what category it's in, and then set it to the side. So, we have, let's see if we have any room. Nope, we don't. All right, so I'll try to squish this in here. We have the probability that first person uses social media and the second person we pick uses social media. And that equals the probability of the first using social media times the probability, well, that's not going to fit. All right, let's try this on a different line. Sorry, guys. It's the probability that the first uses social media times the probability that the second person uses social media given that the first person did also use social media. So when we pick the first person, remember we have everybody in the pile to start with, so that's just like in the previous part A, we have 338 social media users total out of 530 total people. Now, I pick one of those people out. That person uses social media. I send them out into the hall. Now, I only have 337 social media users left, and I only have 529 people total left in the room. So when I go to pick a second person, the probability that they use social media is 337 over 529. And if we calculate that in the calculator and round to a few decimal places, 3 decimal places, sorry, we should have 0.406. So what do you notice about the probabilities we found in parts A, and that should say B, sorry. They are very close, right? Part A, we had 0.407. And part B, we had 0.406. So what does that say? That says if the number of people we're picking is very small compared to the total number of people we have, the difference between calculating the probabilities as if they were independent and calculating them as if they were dependent is very small. In this case, it's 0.001. So that brings us to something we call the 5% guideline. So the 5% guideline says if small random samples are taken from large populations without replacement, and remember, without replacement means dependent, it's reasonable to assume the events are independent. Just like we showed above. So the rule of thumb about when we can do that, about when we can treat dependent events as independent, is if the sample size is less than 5% of the population. So the population we're talking about is the total number of people. So let's talk about independence. Well, I should show you how you determine, I suppose, whether it's less than 5% of the population. So let's go back up here. We picked 2 people out of 530 people. So if we divide the number of people we pick, which was 2, out of the total number of people we have, we get approximately 0.00, and if I round up, 4. So 0.004 is definitely less than 0.05. That's why that worked. And we could pretend they were independent even though technically they are dependent. I think I'll stop here and we'll talk about independence and conditional probabilities and the relationship between the two in another video.